Guys, Mr. Bowman here. Today's learning objective is in like a starry, rainbowy type thing. We are learning to integrate trigonometry and Pythagoras Theory to solve problems, and this is going to have a big focus on how we can use algebra as part of that process. The best way to do these is to go through some questions, so let's get straight into it. I've got a right angle triangle. Here it is, a poorly drawn one. This side of the triangle is x, and we know this bottom side of the triangle is double that, so 2x. We've been tasked, well, how can we calculate the two internal angles of that triangle? And this time around, it's going to be really weird because we don't actually know anything. So we don't know x, we don't know 2x, we don't know y, we don't know z. But by substituting into our equation, something solvable will actually reveal itself from that. So let's get into the question. The first one is you got two angles. Just pick one you're interested in. So let's pick y. So that's going to be the angle where we label from. So the hypotenuse is up here. We don't care about that hypotenuse. The opposite is going to be this 2x, and the adjacent is going to be the x. So that means we're going to be using tan to help us with this equation. So tan angle equals O over A. We're now going to substitute in what we know, and this is the important part. If you don't even try to substitute, the maths won't reveal itself. So let's put that in. So tan y equals 2x over x. Oops, I've written 2x over x. And it's this fraction where the math reveals itself. Those two x's are actually going to cancel each other out, leaving just a number. And that's exactly what we want. That means we can then go ahead and solve. So tan y equals 2. We've now got one variable. Let's go ahead and solve that. Y is equal to tan negative 1, 2. And then when you put that into your calculator, you're going to get 63.4 degrees. And I've rounded that to 1 decimal point. So we haven't quite finished. We've found y, but we've also got to find z. And luckily for us, z will be a bit easier. So z will be equal to 180 degrees minus the other angles, because all of the angles in a triangle will sum to 180 degrees. So we're going to put that in our calculator. 180 minus 90 minus 63.4. That's going to get me to 26.6 degrees. And again, that is also impacted by our 1 dp rounding. So hopefully that question makes sense. Even though we didn't actually know anything, we didn't know x, didn't know 2x, didn't know y, didn't know z, with algebra and the substitution, we're able to find something solvable hidden in all that mess. Now on to question 2, and we're going to do another trig one, and after the trig one, we'll clear the screen, we'll do one revolving around Pythagoras Theory as well. So let's draw my right angle triangle. Hopefully I can do a better job than the other one. So let's say the bottom is x. We know the angle this time. Let's say that's 60 degrees, and let's say that hypotenuse is x plus 1. So first step, label your sides. So I'm dealing with an angle, so it's probably going to be trig. So we've got the hypotenuse here. We've got the opposite here. We don't care about the opposite. We've got the adjacent here. So we're using A and H, which will be cos. So we'll write down our cos formula. Cos angle equals A over H. We then substitute. So just a reminder, substitution often reveals the maths. So make sure you do that process. If you don't do this, you sometimes will just miss what's going on. So cos 60 will be equal to x divided by x plus 1. And if you look at this equation, while there's a lot we don't know, we do know there's only one variable, x. So if we can simplify this, group the x's together, we can go ahead and solve it. So that's exactly what we're going to do. So first step, let's move that denominator to the other side. It's currently division. Let's make it multiplication. So we're going to go x plus 1 times cos 60. That there will be equal to x. This x is now locked away in a bracket. We're going to have to expand. So we're going to go x times cos 60. So x times cos 60 times cos 60, that there will be equal to x. We've now got x's on both sides, so let's move them to the same side. So we've got cos 60 equals x, and I'm going to move this over to the other side as a negative. It's going to be minus x times cos 60. I've now got x's together. I can't think of any other way. I can't really add or subtract them, so what I'm going to do is I'm going to try to group them by factorizing. So we've got cos 60 equals x. So I'm taking that out. 1 minus cos 60. This here is now multiplication. I'm going to move it to the other side as division. So cos 60 divided by 1 minus cos 60 will be equal to x. And when you put that into your calculator, don't forget there's an invisible set of brackets down the bottom. Your answer is actually going to be a nice easy number 1. I'm not sure what my units are, so I'm just going to write down units just to be sure. So I found out what x is. I do need to find out what x plus 1 is equal to, so that's the hypotenuse, and that there's going to be 2 units. So that ended up a lot of mess with our algebra, but we did get to some nice easy answers as well. So at this stage, we've done 2 trig ones. Hopefully you can see how the algebra we've learnt can be integrated into this type of question. I'm going to pause the video, clear the screen. We're going to get into a final messy one in relation to Pythagoras' theory. Okay, our screen is cleared. We've now got our third and final question. So here's my right angle triangle. Save the best one for last. Let's say this side here is x. This side here is x plus 1. This side here is x plus 2. Your job, figure out what is x, what is each 3 of those sides. So first thing to note, we're not really dealing with any of those angles, so it won't be trigonometry. We have all 3 sides as an expression, so that suggests we're going to be using Pythagoras' theory. So let's label it ABC. So opposite the right angle is C, and the other 2 angles join, A and B join to make that right angle. So now let's jot down that formula up the top. A squared plus B squared is equal to C squared. Let's go ahead and substitute. So A, we've decided, was x plus 1 squared. B plus x squared. And C is going to be x plus 2 squared. We're then going to go ahead and simplify and solve. And because there are some x's currently locked away in brackets, the prudent thing would probably be to try to get rid of those brackets to unlock those x's. So those are actually double brackets in disguise. So that's x plus 1 plus x squared, and that there will be equal to x plus 2 I can then expand those brackets. So that's going to be x squared plus 2x plus 1 plus x squared. That will be equal to x squared plus 4x plus 4. I can then go ahead and group these x squareds together. So it's going to be 2x squared plus x squared plus 1 equals, and that other side's unchanged. Okay, now there's not much more I can do here apart from moving all of these to the other side. So let's start off with the x squared. So it's going to be minus x squared minus x squared. We can then do minus 4x minus 4x. We can then do minus 4 minus 4. And when we simplify all that, that's going to be x squared minus 2x minus 3. That there is going to be equal to 0. And this looks like it's simple as it can be. It is a quadratic, which means we need to factorize to solve this. I'm happy about the other side. It's already equal to 0. It's going to make my life a bit more easier as well. So we need to think what numbers are going to add to -2 but multiply to -3. And that there is going to be x minus 3, x plus 1. That there is equal to 0, which means our first answer for x will be positive 3. Our second answer for x will be -1. We've got 2 answers here, and sometimes 2 answers are okay, sometimes they're not. In this case, one of the answers doesn't make sense. So this bottom answer here, -1. So that would mean that side of the triangle there has a length of -1, and that's impossible. I've never given anyone a tape measure, and they've never told me, the side was -1. So we can't have that negative measurement. So we're going to ignore because it would result in a negative measurement. So I'm just being real clear. That's what makes this question a bit tricky. So now I'm just focusing on that first answer for x, and I'm just going to state my three answers. So x will be equal to 3 units. X plus 1 will be equal to 4 units. And x plus 2 will be equal to 5 units. And I'm happy with that because 3, 4, 5 is a very common right-angled triangle. One of the default ones when you're looking at Pythagoras' theory. So guys, hopefully you found this video useful. We went through some real messy algebra / integrating trigonometry and Pythagoras' theory to solve problems. Now that you've done this, I've got a couple examples on the website. Let's get into some practice.